Hi everyone, this is Narayana. Today class is CAN protocol. So in last class I explained UDS, but today I will start a new protocol like a CAN protocol, which is most useful in automotive domain. Okay, this is also one of the most useful protocol in automotive domain. So many of them are asking me or message me message as a to explain CAN protocol. So today I will start CAN protocol. So what is CAN means? What is the abbreviation of CAN? CAN is a controlled area network. So in this network, we used to communicate with one another. Means one ECU to another ECU. By using CAN protocol, we can translate the data from one ECU to another ECU. So let's start the introduction part and what is CAN protocol. Okay. See here, this is the introduction part. So CAN stands for Control Area Network. It is an asynchronous serial communication protocol introduced in the year of 1983 by the Robert Bosch. Robert Bosch was implemented this CAN protocol. Why he is implemented means to know to communicate with the electronic devices like ECUs. Um, so this information we have to transmit from one to another. What is the advantage of this CAN protocol means? It is in a two-wide network. It does not have a bunch of wires. So to avoiding that connection issues, so many different uh, issues to reduce in this CAN protocol. Okay, by using CAN protocol. So CAN protocol is a message-based protocol on a protocol, not an address based. So if you hear about that so many protocols are there, some of them are address based, um, some of them are the message based, some of them are data based. So this type of protocols are there. So to in this CAN protocol, this is a message based protocol based on the transmitting their data is available for all the nodes, and it receives receivers choose to receive the data or not. Oh, whatever happening in this receiver side, the receiver has to choose if the data is received or not. Okay, how it received, if it is received, is there any errors? This type of process is done by the receiver side. So in these CAN nodes are connected in two wires, which is CAN high and CAN low. This is the CAN low twisted pair cable. Means it is a twisted pair. Means it will twisted each other. So in this twisted pair waves, each end we have added a 120 ohm resistor. Why you used 120 ohm resistors, I will explain the next slides. Okay, don't worry about it. So we use 120 ohm resistors in this CAN protocol. So see here, this is the definition of CAN. What how to say the CAN protocol means, this is the definition part. So see, the CAN is a communication protocol between the ECUs in the format of frames. So different frames or messages from one frame to another frame, one ECU to another ECU. So this is the definition of a CAN. So what is the ISO number of this CAN means 11898. This is the ISO certified number. So who developed this CAN? Robert Bosch, in the year of 1983, implemented in Mercedes-Benz or dilemma. Means he is used in Mercedes-Benz vehicles, and dilemmas means here the very heavy vehicles like very heavy like vehicles like lorries, buses. So this is type of vehicles he used first. So what is the speed? How much the data will transmit per second? So means the CAN speed is 1 Mbps per second. So what is the length of CANBus? The length of CAN is nothing but a two wires. These two wires are length is only 40 meters. If you increase the length, if you increase the length of CANBus, for example, if the 40 meters length, it will transmit 1 Mbps, right? So for example, if you increase 100 Mbps, what is the speed? Means 500 kbps. So if you increase 200 meters, what is the uh, speed of message is 2500 kbps. For example, if you increase 500 meters, what is the speed of? It's a 1000 kbps per second. So if you increase 1000 meters, what is the speed? 500 kbps per second. So if the length is increasing, the speed of data is decreasing in CAN protocol. So if the CAN is 40 meters, if the CAN is 40 meters, we can transmit for 1 Mbps per second. So how many bytes of data it will transmit per second or per cycle? One cycle. So it will transmit 8 bytes of data. It transmit 8 bytes of data. Okay, so CAN is a two-wire interface or twisted pair. See, it's a two-wire interface because it has only two wires. One is a CAN high and one is a CAN low. Network consisted of a twisted pairing wire pair wiring between CAN nodes. So it will attach it with CAN nodes, right? So the CAN high and CAN low shorted with 120 ohm resistors at a both ends. See, why we used 120 ohm resistor means I will show you the definition on the implementation in next slide. Okay, please wait for that. So ECU is nothing but a node, right? Here ECU is nothing but node. So from this node, ECU is nothing but a node. CAN is nothing but a CAN bus. Okay, we have to remember these things. ECU is nothing but node. Sometimes I am using nodes, sometimes I am using ECU. So don't confuse at all. So ECU is nothing but node. CAN is nothing but CAN bus. Okay. So see here, what is asynchronous and non-return to zero means? Here the CAN is nothing but a, it is a asynchronous serial communication protocol introduced in the year of 1983 by Robert Bosch. See, I said here the CAN is a communication protocol, is a message based protocol. Okay, it is an asynchronous serial communication protocol introduced by, see, I said asynchronous serial communication. So I will explain what is asynchronous. So what is synchronization definition? I will explain you once. After that you can understand what is asynchronous and non-return to zero values. Okay, so here asynchronous means it does not follows the clock signal. Okay, for example, if you are doing some work, so it will take some time, so it will follows the time. But you are doing some work, it does not follows the time because it may be work, it may be finished in 1 second, 2 seconds, 3 seconds, or 10 seconds, or more than 100 seconds. So more than 100 hours. So we can't follow the time signal. So if you don't know when it is completed, so that's why you are not in followed by the clock signal. So here asynchronous mean is nothing but it does not follows the clock signal. Synchronization means, here see, what is synchronization? It means it follows a time period, particular time period, and it follows the clock sequence. Okay, next is what is asynchronous and non-return to zero means? See here, CAN is a serial asynchronous. Serial means it will transmit one by one. Okay, one by one it will transmit one by one serially. So whenever we transmitting data from one node to another node, see, if you transmit one node to another node, see here, see, this is conversational network, means it will transmit some different types of data from different lines. So this is bus network or nothing but a CAN. So when we transmitting data from one node to another node, what will happen? It will comes first it will comes to CANBus. After that it will transmit to every node. So whatever happening in the here, so it will transmit every node. So all the nodes are activate and read the message. After that, if the message is belongs to the particular node, that node will be reacted. The remaining nodes will be avoid that message or ignore that message. So what happening here? For example, I send here this is you to this is you. What will happen? It does not send this is you to this is you and this is you to this is you. So it is a miscommunication between them. So in this time, what we have to do? We have to connect one more wire to the this is you to communicate with this is you. So this way to avoiding this type of problems. So to avoid this type of problems, we use from this synchronization or asynchronization or non-return to zero protocol. Non-return to zero means the data will transmit continuously. So for example, if you transmitting a message, 8-bit message, so we are transmitting totally full zeros. So what will happen in the zeros? Bit stuffing is happening. So in this bit stuffing, so coming to bit stuffing concept, so we have some terminologies from this bit stuffing. So wait a second. Oh, once again. Yeah. See, in this bit stuffing rule, so it comes to bit stuffing. So in this bit stuffing rule, scan protocol is ensure that receiver does not lose a synchronization. For example, whenever we transmitting the data from one node to another node, so in this bit stuffing is existed because if you send same type of data or same type of bits to ECU, what will happening in the some noises are adding, so it will data may be corrupted. So to avoiding that corruption, so to avoiding that corruptions, we comes a picture has a bit stuffing. Bit stuffing is nothing but after a five consecutive bits or consecutive bits means here after a five same bits. So if you send 8 bytes of data, so in this 8 bytes of data, the first 5 bits are same. For example, the 5 bits are zeros. What will happen? So 5 bits are zeros. So what we have to do? The sixth bit, whatever the sixth bit here, see, this is the sixth bit. In this, instead of the sixth bit, what we have to do? We have to change the value. If it is all ones, then we have to change it is a zero. If it is all zeros, then we have to change one. So to changing this type of bits, to send the sender to send a stream of many bits in the can message me maybe the same or same polarities, because to reduce the data mismatches, okay, to avoid that data mismatches from transmitting one ECU to another ECU. See here, so data transmitted is nothing a synchronized with the external clock signal. For example, if you the transmission of data it does not synchronize, because if you if you send synchronizedly, the data may be mismatches or the data may be corrupted, because the 5 bits of data, if you send same, what we have, what will happen? So sometimes it will change to ones, sometimes it will change to zeros. So this type of, sorry, so this type of mismatches happening. So to avoiding that mismatches, we use the bit stuffing comes picture, and it will act as a bit stuffing. So transmitting of data without any external clock signal, so it does not follow the clock signal. See here, this is an example if you rate it well. So why we are using 120 ohm resistors both ends? So this is the main for why we are using both ends 120 ohm resistors. This is the main question in interviews. So many of them are asking the more first and most question. This is in CAN protocol. If you said I know CAN protocol, they are asking the first question is why we are using 120 ohm resistors both ends. So this is the main interview question for the, for who is preparing for the CAN protocol. We have to uh, know this question, and we have to analyze the answer for this question and says the perfect answer for this question. Okay, then only they consider, maybe some of them are consider you. So he knows some little bit about CAN protocol. So the main purpose of 120 ohm at each end to reduce the noise or minimize the reflections refers. So this is the one point. Okay, so this is the one point from the this 120 ohm resistor to avoiding the noise from, for example, if your ECU is in engine side, so engine is making noise, right? So to, when the ECU transmitting data, the engine noise will add it sometimes. So outside noise added from the ECU through the air, like this type of speed controls. So this type of some noises are adding, so maybe the data will be corrupted or minimizing the reflections, sorry, minimizing the reflections. So every trans receiver has a 60 ohm resistors or impedance. Let's see here, I will show you. So this is the node, right? So in this node, in this is the node. So in this node we have three different types, which is host. First one is host. Every microcontroller will have three different subparts from the ECU or microcontroller host. So this is the host. First one is host. What is the host? Okay. Next one is a transmitter or transmitter. TR transmitter. Okay. In this TR we have some another one is third one. So in this third one is the most important one. Can host. Sorry, this is not this one. Host controller. See, this is second one is a controller, not transmitter. Okay, second one is a controller. So second one is controller. So next one is a next the most important thing. So why we are using 120 ohm resistors from the both ends? This is the comes picture. If you didn't have this one, third one, we can't use 120 ohm resistor, because this third one is a trans receiver. Trans receiver. So trans receiver. This trans receiver. We have 60 ohms for 60 ohms. So to match with each node, every node will have 60 ohms, right? Every node will have 60 ohms. To match this data, for to match the 60 ohms from every node to transmitting data, to match this 60 ohms, we use to match this 60 ohms from the trans receiver, we used the form to use 120 ohm resistor at both ends. See here, I will give you a formula for that, how we match it. Okay, how we used to, so according to how we calculated that. So according to the max power transmission theorem, so source impedance equal to load impedance. This is the formula for to why we used to how to match these 60 ohms means by using this formula. See, according to maximum power transmission theorem, source impedance, here source is can. Okay, what is the load impedance? The microcontroller. See, you can go that. So source impedance is nothing but ECU. Whatever the ECU is sending from the data. Sorry, whatever the ECU sending from the data. So this is nothing but CANBus. This is the load impedance is nothing but CANBus, because the CAN only sending the taking the message from one node to another node, sir, right? So this is the load impedance. So here see, R1 into R2. Here not, R1 is nothing but resistor 1. Okay, this is a resistor 2. So see here, R1 R2 by R1 plus R2. So 120 ohm resistor we are using at both ends, right? So I take in as a R1 as 120 ohm resistor, 120 ohm resistor R2 into 120 into 120 by 120 plus 120. So what is the resultant impedance? Resultant impedance is nothing but what is the impedance, we get 60. So from this 60, so this 60 and trans receiver 60 ohm resistor, right? So this 60 will match. So there is no chance to noise, there is no chance to noise, or there is no mismatching the data. There is no chance to mismatching the data by using this protocol, by using this 120 ohm resistor. See here, I said that every node which we have three subparts, right? One is a host, and second one is a controller, and third one is a transceiver. So what is the key role of host? So mostly a microcontroller responsible for managing all the operations related to the functionality of node. So it is the responsible to maintain the or managing the operations, whatever the operations we are done from that node. So it is the function related to responsible, or every microcontroller we have manage the whatever the operations are related to functionalities that from the node, whatever the functionalities or operations are done by the that node. So it can be used for collecting the information from sensors and transmitting that information periodically or upon the request. Can also be used for activating. See here, whatever the host, what is the main role of host is, it will take the microcontroller responsibilities for managing the operations and functionalities, whatever the functionalities we are done to that by. Sorry if there is any noise, please ignore it. Okay, so It can, yeah, coming to host topic, it can be used for collecting the information from the sensor and terminating that the information periodically or upon the request can also be used for activating. So, for example, if the microcontroller will take the picture, right? So it will take the information from sensors and it will transmitting from the ECUs. So what is a controller? What the controller is nothing but to control or which will managing the operations related to the CAN protocol. Whatever the operations are done by the CAN protocol, it will operates the CAN protocol related messages. So what is trans receiver? This is the main part of the these three subparts. So trans receiver, it may mediator or interface. Okay, it is a mediator or interface from the from CAN nodes and CANBus, which are two different physical standards. If also deals with a speed of a communication, whatever it will deals with speed of communication to transmit. So what is the role of this transceiver means? It will transmit or transmitter can convert the bit level logic to voltage level logic, and in this voltage level logic to bit level logic, it will converts the data from one node to another node while the transmitting. So this is about today session. Okay, this is about today session. uh, thank you for watching this video, and I will give a link, WhatsApp link. Please join on the WhatsApp channel. We will provide the videos whatever we creating without missing any video. We can watch there. So please follow in WhatsApp channel, and please like, share and comment. If you need more explanation or more topics, whatever the topic you have doubt, so please message me in comment section. I will make sure that I will reply your comments, and I will make the videos for the particular topic. Okay, thank you for watching.